In this video, we're going to explore symmetry by rotation in 2 dimensions, and there'll be some questions afterwards. Take this leaf pattern. Rotating the pattern by any integer multiple of 180 degrees leaves it unchanged. We call this twofold rotational symmetry. In the notation used for point groups, we call this C2 symmetry. The point about which we rotate it is called the rotation axis. Let's look at another pattern. Here, rotations of multiples of 120 degrees leave it unchanged. This is threefold rotational symmetry, or C3 symmetry. In this case, it's multiples of 90 degrees with fourfold rotational symmetry, or C4 symmetry. Multiples of 60 degrees here. This is sixfold rotational symmetry, or C6 symmetry. In general, for cyclic symmetry of order n, rotating an object by 360 degrees divided by n leaves the object unchanged. Let's look at the special case when n equals 1. This is the lowest possible symmetry, and we have to rotate by multiples of 360 degrees to leave it unchanged. C1 is the only symmetry where the choice of rotation axis is arbitrary. Next, we'll consider dihedral symmetry. Consider the humble equilateral triangle. It is symmetric under rotation by multiples of 120 degrees. And it is also symmetric by reflection. In fact, there are 3 mirror planes. I'm going to represent mirror symmetry by using lines instead of actual mirrors. Here, the square is indistinguishable under rotations of 90 degrees and by reflection in 4 mirror planes. In fact, all regular polygons obey dihedral symmetry. For dihedral symmetry of order n, there are n rotations and n reflections. Circular objects are a special case. All rotations of a circle are symmetric. The circle does not belong to the cyclic or dihedral groups because there is no single rotation that can generate all possible rotations. This motif is called a triskelion and it's found on the flag of the Isle of Man. What is the symmetry? Take a moment to work it out. Rotations of multiples of 120 degrees produce an object that is indistinguishable from the start. We therefore have C3 symmetry. In 1885, at the age of 19, Wilson Bentley took the first photographs of snowflakes. What is the symmetry of the snowflake? When we rotate by multiples of 60 degrees, the snowflake is indistinguishable, ignoring the small imperfections. We also have mirror symmetry, denoted by these lines. So the snowflake has D6 symmetry. The Eureka flag was flown at the Battle of the Eureka Stockade that took place on the 3rd of December 1854 at Ballarat in Victoria, Australia. What is the symmetry? The flag is symmetric by 180-degree rotations and 2 reflections. We've got D2 symmetry. What is the symmetry of this knot design? I'll give you a moment to work it out. Rotations of multiples of 90 degrees produce an object that is indistinguishable from the start. We therefore have C4 symmetry. How did you go?